Hi, good day. This is once again Teacher Rika, your math teacher. What we are going to talk about is division of monomials. What do we mean by a monomial? It's a one-term polynomial. For example, n squared, a cubed, b squared, c, 24xy are monomials. The skill that you have, or the skill that you should have before dividing monomials, is the mastery in the division of integers. Now, how do we divide monomials? Let's recall, how do we divide 12 over 3? So that is clearly 4, right? But by extending the factors of 12, that's 3 times 2 times 2 times 1 over the factors of 3, 3 times 1, where 3 are the similar factors of 12 and 3. So 3 divided by 3, that is equal to 1. And if we simplify their factors, we will remain with 2 times 2 times 1 on the numerator over 1 in the denominator, which is equal to 4. So that concept will be used in dividing monomials. For example, y to the fifth divided by y cubed. So how many y's are there in the numerator? There are 5 y's and 3 y's in the denominator. So we always put 1 as a common factor of any expression. Now, how many similar factors does each have? So there's one pair of y, which is equal to 1. Y divided by y is 1. Another pair of y, and another pair. So what remains in the numerator are y times 1 as the factors over 1. So y times 1 is equal to y squared, if we can still recall how we multiply monomials. Divided by 1, that's simply the expression itself, y squared. So let's have a shortcut to that. So this concept, if you will see, that is simply subtracting the exponent in the numerator and the denominator. So in the numerator, the exponent is 5. In the denominator, the exponent is 3. So the rule there is just simply subtract the two exponents, but take note they should have the same variable. Okay, so if it's y in the numerator, it's also y in the denominator. 5 minus 3, that's y squared, which is the same with the previous answer that we had. Okay, so that means when we divide a raised to 8 divided by a squared, that will give us a raised to 8 minus 2, which is a to the 6th. So let's have some more examples. How do we divide 21m to the 6th and 3m? So if we will try to expand the numerator, that's equal to 7 times 3 times how many m's? There are 6 m's times 1 as a common factor to any expression over 3 times m times 1. And what factors are similar both to the numerator and the denominator? 3 and m, so that's equal to 1. So what remains are 7 and how many m's in the numerator? 5 m's times 1 over 1. If we will try to simplify that, that is 7m raised to 5. So that's the quotient, that's the answer. Or trying to apply the rule, 21 divided by 3, we know that it's 7, and then m raised to 6 minus 1. So there's an invisible 1 in here. That will give us 5 as an exponent. So they are of the same answer. 72a to the 4th b cubed divided by 8a squared b. So how did we simplify it? Or how did we get the quotient? Simply divide the numerical coefficients. 72 divided by 8 will give us 9 in here. And then subtract the exponents of a, 4 minus 2. So that's in here. And then 3 minus 1, there's an invisible 1 as an exponent of b. So simplifying it further, 4 minus 2 will give us 2 in here. And then 3 minus 1 will give us 2. So the answer is 9a squared b squared. How about 144x to the 5th y to the 10th z cubed divided by 12x to the 4th y raised to 8 z squared. So divide the numerical coefficients, 144 divided by 12, that will give us 12. And then subtract the exponents of x, 5 minus 4, exponents of y, 10 minus 8, So that's in here. And then the exponents of z, 3 minus 2. Simplifying further, that will give us 12xy squared z. Let's have some more examples. How about if the numerator or the exponent in the numerator is less than the exponent in the denominator? It's the other way around. So if we will try to expand the factors, how many y's are there in the numerator? There are 3 y's times 1 over 5 y's in the denominator. So dividing the common factors, y over y will give us 1. So that means what remains in the numerator is 1 as a factor. And in the denominator, 2 y's and 1. Now, if we will try to simplify that, that is 1 over y squared. Now, there's a rule in there. So, in dividing monomials, we simply subtract the exponents, but it will give us a negative exponent. Now, there's a rule. If you will try to simplify it, to eliminate the negative exponent, you simply get the reciprocal of that expression. When you say reciprocal, if it's a numerator, it's an expression having a numerator of 1. You put the numerator in the denominator, and what is in the denominator will be written in the numerator. So the reciprocal of y raised to negative 2 is y over y squared, and when you get the reciprocal, the exponent of y will become positive. So they have the same quotient. So that's the rule. How about w raised to 7 over w raised to 11? So the bar in here indicates division. So that's simply w raised to 7 minus 11, which will give us negative 4 as an exponent. And then simplify it by getting the reciprocal of w raised to negative 4, but the exponent will become positive already. 9b squared divided by 54b raised to 7. So if it involves numerical coefficients, so if we will try to expand it, the factors of 9 are 9 and 1, 9 times 1, 54. That's 9 times 6 times 1. So applying the rule for the exponents of b, that's 2 minus 7. Now, what are the similar factors in here? The similar factors are 9. So what remains for the numerical coefficients are the factors 1 over 6 and 1. And then 2 minus 7 as an exponent will give us negative 5. So if we will try to simplify that, we will write this b raised to negative 5 in the denominator, but the exponent will become positive. So this is the quotient. Let's practice. So let's expand the factor so that you can understand it better. 6d squared, its factors are 6, 1, and 2d's. 6 times 1 times d times d. Factors of 18d to the 5th are 6, 3, 1, and 5d's there. Now, let's single out those factors that are similar. So 6 divided by 6 is 1 already. And then there's a pair of d, which is equal to 1 already, and another pair of d. So what remains in the numerator is just 1, and in the denominator 3, 1, and how many d's? There are 3. So it's in here. And then simplifying further, for the numerator, there's 1 in the denominator. 3 times 1 is 3, and 3d's is d cubed. So that's the answer. How about 64xy to the 4th divided by 8x squared y cubed? So let's expand its factors. So 64 has a factor of 8, 8, and 1. 2 8s and 1. 8 times 8 times 1. And 1x for xy to the 4th and y and 4 y's. In the denominator, you have 8 times 1 for the numerical coefficient, 2 x's in the denominator for its literal coefficient, and 3 y's. So, what factors are similar both in the numerator and the denominator? So, we have here 8, 1 pair of 8, which is equal to 1 already. And then 1 pair of x, and how many pairs of y? 1, 2, 3. So they are all equal to 1. So what remains in the numerator is 8 times 1 and 1y. So it's in here. In the denominator, it's 1 and x, 1 times x. Simplifying further, 8 times 1 times y will give us 8y, 1 times x will give us x. How about 55abc divided by 11abc? So 55 can be expressed as 11 times 5 times 1, and 11 is 11 times 1. And they have the same literal coefficients ABC. Now, simplifying further, that will become 1, that will become 1, that will become 1. And this is 1. And what remains in the numerator? 5 times 1, and in the denominator, that's 1. So 5 times 1 will give us 5, divided by 1 will give us 5. So that's the quotient. How about if we're given o squared p cubed divided by o squared p cubed? So if we will try to expand it, that's 1 times o times o times p times p times p all over the same set of factors. So if we will try to eliminate each or divide each factor, that will give us 1. So any number or any expression multiplied by 1 is equal to 1, is equal to that expression. So if this is 1 times 1 times 1 times 1 times 1 times 1, that's 1. And in the denominator, that's also 1. 1 divided by 1 will give us 1. Now, if we will try to follow the rule, take note, we just simply subtract the exponents in the numerator and in the denominator. So that's o raised to 2 minus 2, p raised to 3 minus 3, which will give us o raised to 0, p raised to 0. It says that any expression raised to 0 is 1. So o raised to 0, p raised to 0 is 1 times 1, which will give us 1. So that's the rule. That means x raised to 0 is 1, 5a cubed raised to 0 is 1, but 2a raised to 0, the base that is raised to 0 is just a in here. It does not include 2. So that's 2 times 1, which is 2. So the explanation to that, why is it that any expression raised to 0, is explained in here. Okay, so here's the activity. If you would like to answer the activity applying what we have discussed today, you can pause the video. So that ends our lesson about division of monomials. I hope you learned something today, and I also hope that you're following all of the other videos I made because they are interconnected. Don't forget to subscribe and click the notification bell to get notified for the next videos. Thank you, and see you for the next lesson.